Now we'll start with hard and soft water. Now, what is hard water and soft water? Hardness may be defined as a property due to which it does not lather easily with soap and is due to bicarbonates, chlorides, and sulfates of calcium and magnesium present in water. So, what is hardness? Hardness means it's a property due to which it does not form lather with the soap. Lather, जिसको हिंदी में झाग बोलते हैं, झाग. It does not form lather with the soap. We can say that is said to be as lather. Hard water does not form lather with the soap. Why? Because due to the presence of bicarbonates, chlorides, and sulfates of calcium and magnesium, it does not form lather with the soap. यदि these substances are present in water, bicarbonates of calcium, like calcium bicarbonate, magnesium bicarbonate, calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate, then it will render the water hard. Otherwise, the water is soft. So, soft water, water which that produces lather with the soap readily, is called as soft water. Like rainwater, distilled water, and demineralized water is soft water. They are soft water. Whereas the hard water is the one which does not lather with the soap easily. They are called as hard water. Example: sea water, well water, river water, tap water, etc. They are called as hard water. We can say that. That is, the hardness of water is due to the presence of bicarbonates, chlorides, and sulfates of calcium and magnesium. We can say that. Now, coming to that is, we will explain the hardness of water with the help of soap. As I said, soap it does not form lather. Hard water does not form lather with the soap. Because soap contains higher fatty acids such as stearic acid, palmitic acid, oleic acid, etc. Stearic acid is C17H35COOH. Alright. Then palmitic acid C15H33COH, oleic acid C15H31COH, in this way. We can say that. So soap is C17H35CONA. So when it reacts with calcium chloride, suppose in water calcium chloride is there, then it will form C17H35CO whole twice Ca, which is a white precipitate, calcium stearate plus sodium chloride. Similarly, C17H35CONA, that is your soap, reacts with MgSO4. Suppose if magnesium sulfate is present in water. I said na, calcium, magnesium. So chloride, sulfates, and bicarbonates of calcium and magnesium. So magnesium sulfate is present in water. It is going to form C17H35CO whole twice Mg, which is also a Curdie precipitate. Alright, so hence plus Na2SO4. So what you find is that is precipitation is caused when hard water is added to the soap instead of forming that is lather. It forms precipitation. Thus hard water is not suitable for washing purposes since a lot of soap is wasted in precipitating out calcium and magnesium ions present in hard water. Alright, remember it. Hard water is not suitable for washing purposes since lot of soap is wasted in precipitating out calcium magnesium ions present in hard water. We can say that. Clear? So you can see it here, the example I can show you, that is soft water, see the lather you can see in the beaker, and the hard water precipitate. Similarly here, lot of bubbles you can see in other picture. You can see a lot of bubbles there with soft water, and the clear water you can see the blue one, and with the hard water is a cloudy water and minimum number of bubbles you can see. Now these are the two things it affects the hard water and soft water. With hard water the scales are formed. You can see the scales, the brown scales are being formed, and in salt water no scales are being formed. So two pictures are being shown there in the below. We can see that that is the hard water one, what it can cause. The hard water, it can cause scales, so which is very harmful, and soft water does not cause scales. Audit and scales is very difficult to remove. We can say that. Clear in this picture. Now permanent hardness is due to the chlorides and sulfates of calcium and magnesium. It is called permanent hardness as it cannot be removed on boiling hard water. Temporary hardness can be removed by simply boiling hard water. Alright, if you boil hard water, temporary hardness can be removed. Temporary hardness can also be removed by Clark's method by adding calculated amount of slaked lime. Remember it, calculated amount of. If you add excess of lime is added, again the water becomes hard. Alright, again the water becomes hard. Water will again become hard due to the absorption of carbon dioxide from the atmosphere by unused slaked lime to form soluble calcium bicarbonate. Alright, so calculated amount of slaked lime has to be added. Again I repeat, if excess of lime is added, it will again render the water hard due to the absorption of carbon dioxide from the atmosphere by unused slaked lime to form soluble calcium bicarbonate. CaOH whole twice plus CO2 will give you CaHCO3 whole twice. So temporary hardness can be removed by boiling and by Clark's process, which is nothing but the addition of calculated amount of slaked lime. We can say that. Or quick lime also we can say that. Permanent hardness washing soda process, we can say that. Permanent hardness, hard water is treated with washing soda, Na2CO3.NH2O, we can say that. It combines with chlorides and sulfates of calcium and magnesium and forms their corresponding carbonates, which gets precipitated. Alright, which gets precipitated, we can say calcium carbonate, magnesium carbonate, you can see it on the screen, it gets precipitated there. Alright, so both temporary and permanent hardness if you want to remove, then you can go for lime soda process. Lime soda process or permuttite process, we can say that. We can say ion exchange method or ion exchanger like permuttite process. So lime soda process is what? This method is employed for the softening of hard water which contains both temporary and permanent hardness. In this method, calculated amount of slaked lime and sodium carbonate are used. Again I repeat, calculated amount of slaked lime and sodium carbonate are used. Slaked lime removes temporary hardness, whereas sodium carbonate removes permanent hardness. Again I repeat, slaked lime removes temporary hardness, whereas sodium carbonate removes permanent hardness. If you want to remove, that is both temporary and permanent hardness in water, then lime soda process has to be used, because for temporary hardness only boiling and Clark's process, for permanent hardness only washing soda process. We can say that washing soda, Na2CO3 plus calcium chloride will give CaCO3 and NaCl. You can see it on the screen. That is a precipitate is being formed which can be filtered off. The precipitate can be filtered off, we can say that. Clear. But for removing both permanent and temporary hardness, lime soda process, that is first we'll be using slaked lime for to remove permanent temporary hardness, and sodium carbonate will be removing for permanent hardness. Or we can go for permuttite process, we can say that, or ion exchange method. Permuttite is a complex inorganic salt called hydrated sodium aluminium silicate with the formula Na2Al2Si2O8.XH2O. You can see it on the screen. The X may vary. In short, we write it as Na2Z. Z stands for zeolite. Z means zeolite, so it is sodium zeolite. We can say the name of the process is permuttite, but the substance which you are using is zeolite. Alright, so why we use this particular process? Generally we use this particular process to make the hard water soft. Alright, we use this particular process, we can say that in different areas, like it is used in hotels, hotel industries, it is used in to wash the clothes in laundries, it is used in industries by boilers. Got it? The boilers, they use soft water, they do not use hard water because it forms scales on the boilers, and scales are very dangerous, we can say that, for the boilers, because economically it is a loss for the industries, and also it may cause some serious accident. The scales, we can say that, which settles upon the inner surface of the boilers, we can say that. So in the industries, boilers are used to prepare steam, and steam is used for the reduction purposes later on. Got it? You will be reading in details in higher classes still. So what you can say, soft water generally is used in boilers, it is used in laundries, it is used in hotel industries, in different places soft water is used, where hard water is never used, we can say that. So there we go for permuttite process or zeolite process, we can say that. Zeolite or permuttite is loosely packed over the layers of gravel and sand in a big tank, you can see that. So I can show you the figure. So you can see the two figures here, the two pictures, you can see it here. That is permuttite or zeolite is being taken in a large tank, and there's a gravel is there, and over that the permuttite is being packed. Hard water is introduced from the top, you can see that from the top, the red one, hard water is introduced, and into the base of the tank. From the bottom, water rises up through the gravel and sand layers and finally percolates through the bed of the permuttite. During this process, calcium and magnesium ions are exchanged by sodium ions. You can see it here, the reaction Na2Z plus calcium gives CaZ plus 2Na plus. Alright, and again Na2Z plus magnesium, which is present in hard water, gives MgZ plus 2Na. Calcium zeolite and magnesium zeolite is being formed, we can say that. Clear? And the soft water, again it is being taken out from the tap, which is at the top. You can see the soft water is being taken out. Alright, so in this way the hard water throughout the day is being made soft. Alright, now at the end of the day zeolite is completely used up. It is being completely exhausted. Zeolite get exhausted, so it is no more suitable for regeneration, for conversion of hard water to soft water. So you have to again regenerate the zeolite. You have to again use up the exhausted permutite or the zeolite to regenerate it again. So how will you regenerate it? So you can see there at the top 10% brine solution is being added into the tank. Generally what we do is that throughout the day the hard water is being made soft in this manner. During the night we stop this process and we add 10% sodium chloride solution, that is known as brine solution, got it, into the tank. Got it, where calcium zeolite and magnesium what you can say zeolite is being present. Now what happens? See, regeneration of the permutite. Calcium zeolite again reacts with sodium chloride or brine solution to form Na2Z and calcium ions. Magnesium zeolite again reacts with sodium chloride to form sodium zeolite and magnesium chloride ions. Calcium and magnesium ions are washed and the permutite thus regenerated. How it is washed? Next day what we do is that we pass water under high pressure. You can see the wastewater is coming out. At the bottom of the tank a tap is there. You can see wastewater is written. From there the wastewater is being taken out. Alright, so all the calcium chloride, magnesium chloride, the precipitate which are being present, that is being thrown out. And we get only the zeolite. But zeolite, sodium zeolite, again it's being present in the tank. In this way, that is sodium zeolite is again regenerated. So this process is very economical. It's very efficient process, very cheap, because very cheapest substance are used. Sodium chloride, which is very cheap, we can say that it's consumed, which is quite cheap. It can be used to remove both temporary and permanent hardness, and it is also very easy to operate. It's not difficult, it's very easy to operate. It's very easy to regenerate the exhausted permutite, we can say that, and again we can regenerate the permutite. So in this way regularly we can carry out this process to convert both what you can say temporary and permanent hardness. We can remove both temporary and permanent hardness which is being present in water, we can say that. In this way it can be, permutite process is a very efficient process, very cheap process, very economical process which is used to remove both temporary and permanent hardness. First we convert, that is hard water to soft water. Then throughout the day this process is carried out, where hard water is being converted into soft water. You can see it here. Throughout the day the process is carried out. Then the permutite gets exhausted. Again the exhausted permutite is regenerated by adding 10% brine solution. Alright, this reaction takes place throughout the night, and again the permutite is regenerated. Again the next day the hard water again it is being converted into soft water. But before converting we remove the waste water which contains calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate. We remove it by passing water under high pressure, and again the regenerated permutite is again it's ready to convert the hard water to soft water, we can say that. Clear? So this is your permutite process or ion exchange method. We have also got organic ion exchange method. We have got that is one is your, that is nothing but known as a Calon process. Calon means calcium gone. The process employs sodium hexametaphosphate NaPO3 or Na2 NaPO4 Na4PO3 which is called Calon, means calcium gone or removed. So how calcium is removed? See, it is in this way. Calon reacts with the calcium ions or magnesium ions present in hard water to form the soluble what you can say salt, and this soluble salt does not cause hardness in water. Got it? Again I repeat, the Calon, which is Na2NA4PO3 that is sodium hexametaphosphate. Got it? So this one it's reacts with hard water. Got it? The calcium magnesium ions present in hard water are rendered ineffective by treatment with sodium polymetaphosphate, we can say that. Rather I should use the word poly, that is the correct word. NaPO3 we can say that, or Na2NA4PO3 that is sodium polymetaphosphate. Got it? Where X is as high as 100, we can say that. The trade name for sodium hexametaphosphate is Calon, which means calcium gone. Got it? And how do this calcium is gone? You can see the equation there, that sodium hexametaphosphate reacts with calcium chloride or magnesium sulfate or calcium sulfate or magnesium sulfate to form the soluble product, and in this way the calcium is being removed. We can say that calcium magnesium is being removed. Got it? So the degree of hardness is defined as the number of parts of calcium carbonate or equivalent to various calcium magnesium salts present in million parts of water by mass. It is expressed in ppm. Got it? If somebody is asking you what is degree of hardness, it is defined as the number of parts of calcium carbonate or equivalent to various calcium magnesium salt present in million parts of water by mass. It is expressed in ppm. That means 1 liter of a sample of hard water contains 1 milligram of calcium chloride and 1 milligram of magnesium chloride. Got it? To 10 to the power 6 parts of water by mass. Got it? Clear? That is said to be as the degree of hardness. We can say that. Now this is, you can see the method for reducing treatment permanent hardness is Calon. This is available in the market. So I have shown you this particular one. This is a salt you can see at the bottom. Just like surf, we are using it. There is a Calon to remove the hardness present in water. And now hardness is removed. I have already said you. Got it?